Okay, today we're going to look at our Introduction to Turtles homework. And this is to prepare us for a quiz um, later on um, this week. So, what we have here is I have the Introduction to Turtles homework up, and I have some recommended resources for you as you complete this assignment. Chapter 4.1 in ThinkPython, as well as the Python Turtle API. You don't have to make use of those resources, but I'm making you aware of them. One of the skills we're trying to practice with this assignment is learning how to use new library functions, just like we did at the beginning of the semester, um, and then using that to solve a problem that we haven't seen before. So I've already given you in the assignment a starter program. Let's start with that. Now, one really important thing to note, do not name your program turtle.py. And that's because we are importing turtle. And if we name our program turtle.py, Python's going to get lost and confused and think we're importing our own program that we're running, which is why if you import math, you can't call your program math.py. It won't work anymore. So I've gone ahead and created a new Python program called myturtle.py instead. And so let's try this out. Let's run it. Let's see what happens. Okay, and my turtle starts pointing in this direction. I go forward. I hang a left 90 degrees, and then it stops. So the different components here is I like my turtle to be shaped like a turtle. That's this first line I have on line 2. I'm setting the speed to be 0, which is its fastest speed to draw, so I don't have to wait. Here are my lines to draw. And then this allows my screen to wait until I exit. And so, for example, as long as I don't click in this white area here of the turtle, the canvas, it'll stay open for me so I can take a screenshot and so I can compare the output of the picture with my code. And I highly recommend you kind of split up your screen real estate so you can have your code and the assignment kind of together, and you can still see this Python overlay, the turtle graphics overlay. All right, so that's what the first bit of code does. Now we want to try and use this code and go forward. So that was step 1. Now let's go to step 2. We want to draw a square to the screen. So drawing a square is really similar to this. I'll demonstrate again. Because really what I'm doing, I've got the first half of the square. I just need my turtle to turn, go forward, and turn and go forward again to get it to draw a square. So let's do that now. I'm going to copy these lines, and then I'm going to show you a way we can do it without copying and pasting, because ultimately we want our code to be dry and we don't want to repeat ourselves. So let me give this a try. Good, I have a square. Awesome. Now notice there is a lot of repetition here, right? I'm going forward, left, forward, left, forward, left, forward. And then if I wanted, I could put a left down here. I didn't, but it's implied. It could be there. Okay, so this looks like I'm repeating 4 times. And the structure that we use in programs for repetition is a loop. So in my square, I'm going to try to draw these lines 4 times. And remember, we have to indent. Okay. So I reduce my repetition. Let's test it. Let's make sure it works correctly. Awesome. And now my turtle is pointing down this line. That's okay. You know, I think that works for this. It starts and ends in the same position, which I think is desired, as a desirable functionality. Okay. So now I drew a square to the screen, and I didn't even have repeated lines where I copied and pasted. And what I want to draw your attention to in this feature is that I just copied and pasted it first. My first step is to figure out what code is necessary to meet the assignment, to meet the problem specification. But once I've done that, I don't settle there. I take that one additional step to analyze my code and from the perspective of dryness, which means don't repeat yourself. Right? So we want to be dry. Okay, we don't want to repeat ourselves. And so I took that second step, and that's the process I recommend you follow. First, get your code working, solve the problem, and then take that one final step. It's like not submitting an English paper that you've written in your first draft. You take one more read through to catch anything you might have missed. This is the same idea. And this is the process that will help you teach yourself and learn how to write really clean, efficient programs. And gradually, you can teach yourself every design principle that I could teach you in a software engineering course by just analyzing your code in this way and trying to ask, how can I do that better each time? So it's a process of self-reflection that really drives your learning. Okay, now the instructions are asking us to change its color, and I do that by going above my square drawing, and I think maybe set color. Well, I'm not sure. Change Python turtle color. Let's try that. I don't know. I don't remember what the function is, and it wasn't popping up. And we're not using Python 2.7, so I recommend, oh look. Look, there's Python turtle color change, and there's, oh, color. It's just called color. That's it too. So here we've got turtle.color here. But an even better resource, I think, in this case, as much as I love Stack Overflow, is the Python documentation. Because it has a list of every function that you need. And so here they all are summarized in 24.1 point. Here, turtle methods. It's got everything: position, color control, pen color, fill color, or color. So let's just try color. Not quite sure why it's not coming up, but that's okay. And then let's try red. Let's give that a shot, see what we get. And now I have a red square. Awesome. Okay, make the line thicker by changing the pen size. Okay, turtle dot pen size. For some reason, these aren't coming up. I'll just make it 4. I don't know. Pen size here, there is a pen size function. This pipe means or, this symbol here. So we can see on this line, pen size or width. So you can see aliased functions. Ah, yeah, it worked. Great. That looks good. And then change the speed the turtle draws. So it's already at 0. I can make it 4 just to slow it down. I'm not going to leave it like that because that's going to slow down my development process. But you can see that turtle drew a little bit slower than before, just as means of comparison, right? That drew much faster. So I'm going to leave it at 0, but I did complete all of these steps. Awesome. Now, if you were struggling to reach this point on your own, now that you've seen it, I would pause, keep going, and you pause the video, try to work on the next step, and so work one step ahead. I'm going to go on to step 3, draw 2 squares. It's possible to move the turtles without drawing. And again, I'm leaving the turtle speed to be 0. The function we need for this is called pen up. So here it is, pen up. I can also use PU or up for short. So I'm going to draw my square, and I'm going to try and change the color to be blue here. And now I need to move my turtle over so I can draw my other square. So I'm going to say turtle dot pen up, turtle dot forward, let's say 200. The reason why I picked 200, my turtle, when I run it, here I will run this so you can see. When I run it, you can see my turtle's already blue. I end up here and I'm facing this way. So when I move the turtle forward, it's going to go this direction. I have said that each side of my square is 90. So if I want spacing between this square and my next square, I need this space to be greater than 90 the square's side. Okay, so you could do 100. I'm going to try 200. Maybe it is safer to do 100. I might get off the screen. So it just needs to be greater than 90. And then, want to draw again, I want to put the pen down again. So you can almost think of the turtle as like a turtle with a can of spray paint, and everywhere it walks it sprays, but you can ask it to turn the spray paint off, on and off. And that's what we're doing here. Okay, and now I just need the code for a square. Again, I am copying and pasting. Oh, it makes me cringe. I don't like copying and pasting, but we're gonna leave it just for a minute, to show you the development process, and then we're gonna fix it. We're gonna fix this in just a minute. All right, so let's give this a run and see if it looks something like the picture right here. Yes, it does. I have two squares. They are side by side, and they are right next to each other. And so this gap is 10 pixels, and the size of each square is 90 pixels. Awesome. Okay, now we want to create a square function because that's how we eliminate this copied and pasted code. It's not appropriate to use a loop here. So loops and functions are the two mechanisms that we most often use in this course to reduce repeated code. And I can't really use a loop because I don't want to repeat this code. So the best thing I can do is to replace this and this with a function. And what I want to do is make it a generalizable function that can be used in many scenarios. It also says that we should use a loop. We're ahead of the game. We've already got that loop built in. So we're using our loop to draw our square right now. So all we have to do is create the function itself. So I'm going to scroll to the top. Best practice is to place functions in between the import and any other statements that execute. I'm going to start by moving one of these squares up here. And you'll see why in a minute. Because I am going to make this a square function. And I can tab all these things over. Now, let's see. Create a square function. Revise your program to include a square function. It takes the length of each side as a parameter. So right now I've created a square function with 0 parameters. But the assignment is asking me to create a function with 1 parameter, the length of each side. So I'm going to look at my code and identify which of these numbers is the length of the side. Here I'm turning left. That's the angle, 90 degrees. That's not going to change no matter what size my square is. What's going to change is here. So I'm going to create a parameter called length, and I'm going to replace 90 with it. Okay. So now I need to call my function. I can include as many functions definitions at the top of my program as I want, but if I don't call them, they'll never get executed. So I was using 90 before, so instead of having 90 here, I create a parameter. So there's a variable now in my function for this length, and instead I bring that 90 in when I call it. And now I can do the same thing here, and I can replace this loop with a call. And so my code is a little bit cleaner. Now, let me see if I can pull this down so you can see it. So I've got my function defined once up here, and then I've got my call set function. So my code is significantly simpler than it was before. Now let's test it, make sure it works. Ta-da! And it looks exactly the same as it did before, which means we changed our code correctly. That process is called refactoring, if you ever come across that word. So we refactored our code to have a better design, even though it didn't change the output in any way. That's going back to the same steps we used with the loop and trying to make our code more dry. We didn't change the functionality, we changed the design. We made it easier to work with in the future. Awesome. Okay, so now we have our square function. I urge you again to pause the video and move on to step 5, creating a rectangle function. I'll wait. All right, have you tried step 5? I'm going to move on to it, assuming that you have taken a stab at it yourself using the square function as an example. Okay, so I'm going to start from the square function. I think I love, sometimes copying and pasting is handy. Like if I want to create something that's similar but not identical to something I've created before. Okay, so this one's going to be called rectangle. And let's read the specification for the function in step 5. We're going to generalize our square function by creating a rectangle function that takes a width and a height as parameters. So this is actually going to take 2 parameters. So I can't use length anymore. I'm going to use width and I'm going to use height. Okay, so when I go forward, I have to pick one, width or height. Now, if I left the function like this, I would draw a square where each side is width. But what I want is to be able to draw a rectangle. So I'm going to copy and paste these lines again. This is an acceptable version of copying and paste, or an acceptable instance of copying and pasting, because I'm going to change it to do something different. I'm going to have it go height. So I'm going to go forward the width and then up the height, and then forward the width and down the height. Now, I also want to update my loop because I don't want to repeat this 4 times. I only need to repeat this 2 times. All right, let's run it. I'm not finished yet. So running it doesn't do anything. I just added a rectangle function, but I haven't called it. So there's no change. So let's pick our second square and make that a rectangle call. Let's say we'll do rectangle 90, 150. All right, let's give that a shot. So now I'm calling my rectangle function. I defined a rectangle function up above before, but since I never called it, this code was never executed, so I couldn't actually test it until I called my function, which I'm doing here. Let's give it a shot. Woohoo! I have a rectangle. Awesome. Okay, so we've completed step 5. Now in step 6, we want to draw a picture using our newly created square and rectangle functions. Ideally, we want this to use a for loop, and that loop should call rectangle or square. And we shouldn't be using any user input. So let's give this a shot. Let's start. We can start with square. We'll go with square. So I'm going to remove some of the code that I've been using. Okay, I've made everything red. I've made the pen size big. So I want to put my square inside a loop. For I in range 10. Let's see what happens. I'm going to draw a square. And then I want to turtle dot right. Let's see, I'm going to do 10. I'm going to draw 10 squares. A circle is 360 divided by 10 is 36. So this is 360 divided by 10. And I'm going to comment these lines down below out. The way I can do that quickly in PyCharm is with the command or control /. It's under the question mark key. It's the question mark key. So I used the loop, called square. Let's see what happens. Ta-da! And now I used my square and made a pretty shape. And that'll complete my assignment. The last step is to take a screenshot. Please, when you take your screenshots, make sure to show your code as well as the final version.